Yeah.
Let's
Hi,
hope.
everybody. Thank you. Thank you. Thanks, Dimitri. Yeah. So my name is Seth Thompson, and I am a product manager on the Google Chrome team. And specifically, I work on the JavaScript engine, V8. The V8 team is based in Munich, but we have Googlers working on the project from 5 offices: San Francisco, Mountain View, New York, London. And we have a whole world of contributors who help make the project what it is. So thanks for inviting me here, and let's get started. Now, before I begin, I want to say that my flight was delayed from Munich last night, and the rerouting took me from Munich to Frankfurt to one airport at Kiev to the other airport at Kiev to Minsk. So at 2:30 a.m. I was here. I have not slept, and I apologize for any syntax errors or misspoken words in this presentation because of it. But anyways, let's get started with the presentation itself. So you've heard a lot about ES2015 or ES6, and you're probably actually rolling your eyes right now and grumbling and saying, okay, it's going to be another ES2015 presentation. But I hope this is different than the presentations which, introduced this new language and talked about its features. Because we're at a point in time where actually the future is now. We've reached a milestone where many browsers are very close to being done with shipping this new extension to the JavaScript language. So the year of the future is 2015 apparently, and even though we've started 2016 already, I think there's a lot of excitement in the industry that some of these features are finally going to be able to be used natively in browsers. So, and that's what my presentation is about. It's about using ES2015 in the browser. But let me back up and start with a high-level overview. This may be very familiar to you, but bear with me. So ECMAScript 2015 is the name of a version of the ECMAScript language. And ECMAScript is this product of a standards body called TC39. And this is a group of people that get in a room and they figure out what should be in the JavaScript language. Year to year, what features can they add to make developers' lives easier? What patterns are developers writing in JavaScript that are too slow and that they could make faster if there was native API support for something or native syntactic sugar to accomplish the same goal? And they get in the room and they collaborate. There's members from many different browsers, from the Node.js community and from other from academia who study programming languages, and they design and ratify updates to the language. But ES2015 is really special, ES6. And the reason it's special is because it's the first major update to JavaScript since 2009. And not only is it an update, but it's a really, really big one. So the update to the language is written out in a spec. You can visit it on, if you just Google, ES2015 spec, you can load the web page. So I did that this morning. I loaded the ES5 web page, which was the previous version of JavaScript, the one that was released in 2009 and ratified then. And then I loaded the ES2015 spec, which is the new features that have been added. And I couldn't even take a screenshot of the web page without my computer crashing. But this is the approximate length of the pages here. So ES2015 is more than 2 times as big as the last update. And what that means to you as developers is there's a lot of features in there and plenty that you probably haven't heard of yet. So there's a lot to discover as you use JavaScript and see it evolve over the next couple of years. And then on the other side, for the browsers who have to read this whole thing and implement the semantics and syntax described in this really pretty dense spec, it's taken a long time. So where are we? So, ES2015 has a bunch of new features. You've probably heard about these, so I won't go into too much depth. Or if you haven't heard about them, you can Google them and search on the Mozilla Developers Network or some great tutorials already out there to learn about them. But there are things like classes to make object-oriented programming much easier in JavaScript and getting things like inheritance and subclassing out of the box. Arrow functions, much faster syntax for writing lambdas or for writing really compact functions, anonymous functions, and they bind this context, which is useful. We have things for destructuring, default, spread, and rest parameters. These are like syntactic sugar that just make dealing with arguments to functions and arrays a lot smoother. You can remove a lot of boilerplate from your code with this. Template strings are really useful for inserting variables in the middle of strings. We've got let and const, which are, you can think of as the big brothers to var. So there are different ways to scope variables in JavaScript in block settings. We've got iterators and for of, so you can have a really nice for-element in array, for-element of array. Generators to make it easier to create iterable objects, or yes, objects. Modules for organizing your code, being able to split your code into separate files and importing different ones with very precise rules. We've got some cool new map stuff. Proxies are something which haven't been talked about much because you can't use them today. You can't polyfill them. So unless a browser has implemented them natively, there's not much experimenting you can do. So we're going to talk about those later today, actually, and hopefully you can learn some new things about what is one of the most powerful parts of these updates. Anyways, and the rest you can kind of read there. I don't want to dwell too much on the individual features, but suffice to say there are a lot of them, and a lot of them are really, really useful. And the exciting news, and this is really pretty recent, is Chrome just announced that we now support 91% of ES6. So forget what people told you about needing to polyfill all of these features or transpile your code with Babel. We're so close to being 100% of the way there, and today you can use almost everything that you want to. So this is no flags needed. It's shipping by default, and Chrome 49 isn't quite out yet, but you can pick up all of the changes and see what the release will be by downloading Chrome Canary, which is our early release version before the stable version gets sent out to all of the users in the wild. So the missing 9% are a bunch of little things. There's tail call optimization. That's actually not quite so little. That allows you to create recursion that doesn't blow up your stack after you recurse too much. Some things related to well-known symbols, some miscellaneous proxy calls and traps. But really, the point of this slide is that that 9% is probably not the features that you're itching to use. So Chrome does support this stuff. But it's not just Chrome. And other browser support is really, really good. We've made incredible leaps and gains in the last just 2 to 3 months. So Edge's latest release version is now at 83% support for ES6, ES2015. Firefox's latest version is at 85%, and WebKit is at 82%. These are good numbers, and we're closing the gap to the rest of the 100% very, very fast. And in sum, you can say as a general statement, this is probably more important than anything about one particular browser. You can say that all major browsers support at least 80% of ES2015 in their latest developer releases. So this is really good. We're close to 100%, and I think it will happen very soon that you'll see people announcing them being done implementing this new part of JavaScript. And just to go back to this last slide, obviously it's hard to keep track of which browser ships what support, but I recommend this site if you just search Cangax compat table or Cangax ES6. You can pull it up and it shows you what features your current browser supports as well as the matrix of all the different browsers and how far they are along in shipping ES2015. So this is really exciting, and And what this means is, for the first time, you can really start experimenting with the language in your browser. But don't get too excited yet, because the latest versions of the major browsers support all these features. But it's true, we can't forget older versions. And there's a vast majority of the web that unfortunately still does not have features like classes or proxies or destructuring. So you can't just go out and ship your code with ES2015. So, we're in this in-between stage. And I'd like to talk briefly. I think there was a talk earlier this morning on actually writing a transpiler. So I won't go into too much detail here. But, these are the tools we have to deal with this long tail of old versions of browsers that don't support ES2015 features. We have transpilers, which take in the code, which has these new language features. Maybe it has some keywords like class, or it has some new symbols like the ... before an arguments object to signify spread or rest behavior. So it takes that code written in ES6 and it basically just rewrites it in older versions of JavaScript, re-implementing sort of the same behavior, but in more verbose often ES5 JavaScript. So those are transpilers. And then there's another set of things which are like primitive objects or new APIs, new behavior that the browser is in ES2015 is releasing for the first time. And you can't quite just rewrite your code to get that. But polyfills exist as libraries to sort of patch up the gaps in coverage. So anyways, you guys know this, transpilers and polyfills. And here's an example of that rewriting for transpilers. So on the left, I've written my beautiful, very simple, short version of an exponential function here called power. It just takes an argument x, and if you don't pass in a y, it just squares it. And if you do pass in a y, it raises x to the yth power. That's hard to say. So if I pass in 3 without a second argument, it squares it. If I pass in 3 and another 3, it cubes 3. So that's easy. That's ES2015, the default parameter there and the top line. Now a transpiler takes this and it rewrites the same behavior, the same semantics, in a longer, more verbose code that doesn't rely on these new features. So first it's got to check if you've passed in more than one argument. If you have, then it says that arguments 1 the second argument is 2. If you haven't, then it just returns the original one. And then you can accomplish the same behavior, but it takes more code, it's more verbose, and you've had to rely on this tool to sort of do the translation for you. And of course, I should mention, why do people do this at all? Well, it's because they hope that someday in the future, they can turn off the transpilation process and just use the left version, the clean, short ES2015 version in the browser natively. So, but we've got these tools, we've got these transpilers and polyfills. So, why do we care at all about how fast the browsers are shipping features? You can go out today and download Babel, take your ES6 program, compile it to ES5, and run it. That will work for the near future. Why do you need to care about whether the browser itself finally ships support for class? Well, I'm here today to tell you about 4 reasons why you should care about native support for these features in browsers. So the first one is big, and it's that a polyfill and a transpiler can do their best job to rewrite your code or patch in new functionality, but they just can't replicate all the features that a new language can, or ES2015 can. So I'll talk more about that in a second. The second reason that you should care about browsers shipping these features versus transpiling them is that cost of transpiling and polyfilling your code is both overhead in the size of the code that you're sending down the wire to your customers or your website visitors, and it's costs in how long it takes for that code to start up when it loads. So there's a performance impact here. The third reason is, and you've probably run into this if you used Babel or Tracer or Browserify, any of these pre-compilation tools. They make debugging more complex. It's not that it's not possible to figure out what's going on, but with every step in your compilation link, it gets harder to trace back a buggy behavior to the original source. So native browser support for ES2015 makes debugging a lot easier because the browser's good at telling you when there's an error in your code. And DevTools is much more likely to give you a good answer for what's going on than the Babel library is, or the combination of all of these different libraries you're using together. And then finally, the promise of adding language support for a feature is that browsers and VM implementers like V8 can make that feature really fast. So it's much faster to expose some primitive called, let's say the for-of or the for-in feature, and rely over time on browsers to make that implementation really fast than it is to get the same behavior in more code using ES5 without those guarantees of sort of the behavior being as fast. So I'll talk more about those in a second. So polyfills and transpilers, unfortunately, can't replicate all features of ES2015, or for that matter, future improvements to the ES language. So here's some big ones. Proxies right now are totally unusable with polyfills and transpilers. You'll see why in a second, too. Proxies are this really powerful mechanism that really you can only get at if you have native support in the browser. You can't really transpile code and get performant tail call optimization. So that's for being able to call recursive functions with tail calls really performantly and without blowing the stack. The browser just doesn't let you, even if you have a polyfill or a transpiler, subclass some primitives like array or date or error. So if you've ever wanted to extend the array object to add your own method or something, people tell you don't do that, because if you extend the array primitive, then any code that's running in that same context will be exposed to your side effect that you patched in. So people, you always want to make local changes only. But you can't subclass array to something like myArray, which you might add methods to or modify, because those three primitives are just not subclassable. The browser says they aren't. That is before ES2015. And finally, you can polyfill in something like the Reflect API, but you don't actually get the browser recognizing the name Reflect as a primitive. It just says, oh, this is a JavaScript object like any JavaScript object. Anyway, so some of these, you're getting into the sort of the more minor details, but fundamentally it's true that you can't polyfill or transpile everything. So that's why we need native support. Native code, I mentioned this, requires less code. Native ES6 requires less code to accomplish the same actions, and it's faster to load. So let me take a look. I showed you earlier the default parameters comparison. That was pretty simple. This is, on the left, an ES6 iterator, and we're iterating over this Fibonacci sequence here. That's an ES6. Very concise, very easy to read. And this is what comes out of a transpiler, which says to duplicate the functionality on the left in the new version ES2015. To duplicate that same behavior in the old version of JavaScript I already know, ES5, I have to do all of this work, and I cut it off too. It's even longer than the screen. So it's just such an inefficient way to get the behavior that you want. You really want a browser that just supports the left by default without you having to jump through all these hoops and add all this extra code to your app to accomplish the same thing in ES5, in older browsers. So there's a couple other pitfalls here related to kind of how your code builds up and increases in size. So you start with these really short, beautiful, you guys are all good at writing code, a beautiful ES6. Syntactically perfect, really compact and concise. You're really proud of it. And then you go to transpile it. And Babel gives you this semantically correct, but like massive, massive ES5 files here to accomplish the same actions. So you say, okay, I can kind of deal with some of the extra code if it allows me to ship this functionality in older browsers. I got that. But then Babel's also got polyfills that it needs to provide, runtime objects or new APIs. So it sticks these polyfill implementations in. And it can be smart about it. It only add the polyfills that you used, but you're still talking about a lot of code when you started with such simple, beautiful ES6. And then you're not done yet, because what comes out of Babel or another transpiler is some module format. Maybe, there's all these JS module formats. You got Common JS, AMD, UMD, there's ES2015 modules. But anyway, so you got some individual modules that come out of the transpiler, but to get it to your users, you've got to bundle it somehow together. So then you pull out Browserify or Webpack, and by the time you get to the end, you've got not just this massive amount of code, but it's gone through all these steps in transpilation that it's difficult to reason about your original code anymore, and it's difficult to debug, and more importantly, this big chunk of extra shims and magic takes a lot longer to load in the browser, both over the wire and as the browser sort of reads the JavaScript, parses it, and loads it. Just takes a lot longer to get to the actual action. So again, this is a reason why ECMAScript native support for ES2015 is really important. It saves a lot of that extra code. These are some of the tools I mentioned. It's worth understanding them. I mentioned that we can't just switch over to native ES6 yet. We do still have to support older browsers. And as long as you do that, as long as you do have to jump through all of these hoops, you might as well optimize that and really understand the tools available to you to get the most efficient final form. So you've got Babel and Tracer primarily for the transpilation from your ES6 to ES5. You've got Browserify and Webpack that do sort of very magical bundling. You've got this thing Rollup, which also does bundling, but it has this special thing called tree shaking, where it analyzes which modules you've actually used and only includes the one you have. Then you've got this thing called Closure, which is old Google technology. Not old, it started a long time ago, but it's actually very modern now. And that does all of the above, but it produces this minified code as well. Anyways, it's a mess kind of to understand and grapple with, but it's very important for this reason. A colleague of mine named Sam McCone recently put together a chart that analyzed the cost in bytes, compile time, and when you're developing, time to actually generate the ES5 transpiled code. He measured out all of these for various combinations of these tools, Closure by itself, Browserify plus Babel, Babel plus Rollup, Webpack plus Babel plus Ugify. And you can see here that there's actually vast difference between the various options. And ultimately, if you want your users to have a snappy site that receives this code and runs it as fast as possible, it matters whether you choose something that takes, that sends 18 kilobytes over the wire versus 2.8. Or whether when you get it in the VM, it takes, I guess what's the shortest there? The 43.9 seconds to execute versus the longest 66.6. These numbers really matter. And so, you should go to this repo yourself and see in detail the configurations that he did to get these numbers. But my message would be, while we have to put up with polyfills and transpilers, take the time to kind of understand the different tools and pick the best ones for your use case. So the third reason why you should care that ES2015 is finally coming to browsers is that it's just so much easier to debug, and it's got a faster refresh cycle. So refresh cycle is the time after you make a change in your source code, which is ES6 or ES2015. You hit save, you do some compilation step or gulp or grunt or something to transpile it to ES5. You got to wait for that. Then you tab back over to your browser and you hit refresh. That's the refresh cycle, is the time from when you type the character in ES6 and you can preview it in your browser going through the whole transpilation thing. Native ES2015 just jumps through a lot of that waiting time, and as a developer, it's a lot better experience. So here, I'll give you a quick demo. How many of you are familiar with To-Do MVC? It's this It's this implementation of the same app, a to-do note-taking app, in a bunch of languages, or excuse me, a bunch of frameworks. So it's got a React and an Angular version, vanilla JavaScript version. They also have one which is a pure ES6 implementation. So that's what we're looking at right now. And in particular, they have, and I don't know how well you can see this. Hopefully it's a little bit, you can see it a little bit. They've got their ES6 source. You can tell it's ES6 because you can see the class keyword. You're exporting something in module syntax. You've got arrow functions here. So this is definitely ES6 source. And this is the To-Do MVC example online. They're compiling it by running it through Babel to translate it to ES5, and then through Browserify to wrap it up in a bundle. So anyway, so let's try that. So we got, we have this this npm script here, but I'll type it out explicitly so you can see it. You've got your Babel source, and you're going to put it to the dist directory, and then you're going to run it through Browserify and create this bundle. So here's how long that takes. It's not that short, and every time that I come in here and say, you know, I change my app name to do vanilla JS2, I got to save, I got to tab back, I got to compile. I wait for this to go again. Okay, and now I would be ready to refresh my browser and see the result. So it's not trivial in terms of time. And there are definitely things you can do. You can add in some crazy gulp plugins to watch your files and automatically recompile every time you save. But either way, there's a lot of work that's happening in the transpilation process while you're developing, between when you can see the effects of what you're coding and what's running in the browser. But here's the amazing part. I just thought, well, wait a minute, this to-do app is probably not using tail call optimization or some of the 9% of ES2015 features that Chrome is still working on. It probably uses stuff that's already implemented in V8. So I have the exact same source in this other folder called native. And for this, all I'm doing is concatenating all of these 5 source files into one dist file. You know, there's a slight, I don't want to get too far into the weeds here, but one problem with ES6 code still is that modules, the actual units of code, are not yet available in the browser because the standards committees are actually still figuring out how loading ES6 is going to work. So it sounds kind of funny, but even after we implement all the ES6 features, you might not still be able to just include an ES6 file in your browser because that loading process of resolving the URL and loading it is still being spec'd out. So anyway, so I'm going to use this tool rollup, which doesn't do anything except concatenate them together and put them all in the global namespace. So you can see it's not doing much because it's very, very fast. That was it. It's done. And I'll pull up what it looks like. So you can see here, all of the ES6 syntax is still there. You've got the class keyword, you've got your arrow functions, you've got, you know, template strings here somewhere. All it did was it just concatenated these together and put them in a global namespace. So anyway, so with only that work on my ES6 source, it turned out, and I got lucky on the first time, it just runs in Chrome today. So this is, if you right-click and inspect the source here, we're running, where is it? We're running this ES6. You can see an arrow function there in the browser natively. So this is really cool. And in particular, what this means is you might not be ready to ship ES6 to your users because they haven't updated their browser yet, or they are on one of these older versions or a browser that hasn't implemented these features yet. But you, as a developer, doing nothing more than upgrading to the latest version of Firefox or Safari or Edge or Chrome, you can take advantage of native ES6 support to skip transpilation while you're developing and debugging. So here's another interesting little quirk about this. I'm just going to pop 2 changes from my git stash here. So this is creating, I think this worked, it's creating an error in the code somewhere. So when I do that same thing, let me switch back over to the transpiled code. So now I'm going to pretend I'm debugging just the old transpiled code again. And I compile it through Babel. You know, I wait a bunch of time, and I get this weird error. It says, this is not allowed before super. So I have no idea what this means. You know, I'm familiar at a high level of the ES6 classes, but I can't understand what's wrong in my code and what I might have to fix if I'm sitting here looking at my source code. But if we take the same source code, the same error, and we run it through that other process, the native version, and we just do rollup to put the modules and concatenate the modules. Go back to our native version, and I refresh. Actually, I don't get the error at the time I got it on the transpiled, but I do get an error in my console, and it says something here. It says class extends value, you know, hashtag object is not a function or null. Okay. I still don't know what it means, but I've got I've got the source, the line where this error occurred. I didn't have this when I had passed the code through Babel, and it underlines exactly the line and what it does, and it just basically says class extends something is not a function or null. Well, that's true. An empty object is not a function or null, so this probably is my problem. And immediately I found the answer because, you know, DevTools or your browser is just so much better at telling you what the actual error in your ES6 is than your transpiler is, which is probably going to run into something syntactically, or, you know, it's going to have a harder time figuring out what the error is because it doesn't actually understand ES6 in the same way the browser does. So I think that was the error. Let me go back and just confirm it. I think that was in my app. No, maybe my controller. Let's search for it there. Oh no, maybe it was in the view. Let's see what file it was in. To do, the constructor for to do. Let's see. There it is. It looks. Oh, this is my dist. I got to go to the source here. Okay, here it is. So I found it in the original ES6 source. I just delete that. I hit save. I do that very fast roll up again, and I refresh, and my error goes away. So you can kind of see. I don't want to go too deep into this, but you can kind of get a sense for how debugging and developing in a native ES6 environment is just a first-class experience, while getting the same results after running your code through transpilers is going to be a lot harder. You're going to be up against a much harder task. So, anyways, back to the presentation here. So, easier to debug and much faster development cycle. The last point I want to make is that, you know, optimized native ES2015 will be faster, you know, during the runtime. We talked about the performance costs at loading. It'll also be faster during runtime than ES5. Now the asterisk or the caveat here is it's actually not quite faster yet. So you can go to a page called 6Speed, and it basically compares all of the browsers and all of the different ways you can implement functionality like an iterator or an arrow function, and it compares which is faster. And so actually native ES2015 today is not as fast as the ES5 code. But that's just because, as browsers, we finished implementing the thing weeks ago. it's going to take us some time to go back and actually optimize our implementations. But I promise you, we will be much faster in the end than, if you remember that earlier slide, that long, 20-page long version of an iterator. So this is sort of a promise for the future here. It will be much faster with time, and if you want to write future-proof code that takes advantage of that speed over the long run, you should definitely write in ES2015 as a native feature. Actually, just in the last release of Chrome, to give you an idea of how fast we're talking about it, we improved the speed and the speed and rest operator by 8 to 10%. I mean, 8 to 10 times. So that's 800 to 1,000 times percent. So that's really big, and that was just in a couple weeks. So when I mean that it'll get fast, I mean it'll get fast soon, and it'll get really fast. Okay, so we've talked about these features, and we've talked about ways to blend this workflow where you're probably still shipping transpiled code to your users, but as a developer and as when you're debugging, you can probably start using ES6 today. So it's time to really dig deeper between these polyfillable features, to create a bad word there. The features that can be polyfilled today, like classes and the spread and rest operator, the syntactic stuff. And in particular, talk about this magic thing called proxies. So how many of you have heard of ES2015 proxies? So a couple people, okay. I guess I would have to compare that to another popular feature to see if that's greater or less than normal. But regardless, I don't think they've gotten much coverage, and few people have really written tutorials on them. So I wanted to quickly give you a sense of what this feature will do. And again, remember, this is one that you can only use when the browser supports it natively, which we do now. So proxies allow developers, and this sounds kind of complicated, but bear with me here, I'll break it down. Proxies allow developers to intercept operations on an object and perform custom behavior for those operations. So what if you could increment a variable every time somebody got or accessed a certain property? So what if I had my object.foo and somehow I could keep track of how many times foo was called? That'd be kind of cool. You can't do this today in ES5, or at least can't do it in a general way, in a way that applies to all these examples. What if you could validate a value before setting it on a property? So I've got a person object, and I've got the age property to hold the value for how old that program is. In JavaScript today, I can put a string on age, and it's fine. Nothing happens, nothing goes wrong. But if I'm creating a person object in sort of a strict sense, that age should be an integer, should represent the years in integer form of how old that person is. So what if you could actually validate that a value meets a certain criteria, like is an integer, before setting it? Here's an example. You can set person.age. You can see that it was set. But then if you try to set a string to that property, it's going to throw an exception. This is new behavior. This doesn't exist in ES5 today, and you couldn't create this even if you really wanted a very strict person object. In this example, they've also set a validation limit on how old a person realistically can be. So if you try to set it as 300, that also throws an exception. So again, proxies are going to be by the way, just as the punchline here is proxies allow you to do this. And I'll give an example of basically how it works. So let's take that last one. You want to basically validate that a person is that you're setting the age property to an integer. So you say, I want to validate the properties on my object somehow. Okay, I'm going to explain at a high level what happens using the magic of proxies, this new feature, and then I'll show you the code. Okay, here's a new vocab word, handler. This is something that handles operations. Surprise. So you create this thing called a handler, and you basically tell it, whenever somebody performs a get on my property, I want to just do a normal get. Just give the value back to them like you normally would when you call foo.bar and get something back. But you can tell this handler, when somebody tries to set a property, on our person object, make sure the property age is an integer before you set it. So this is just sort of formalizing what we talked about as our desired behavior, our goal. Okay, so you're going to create something called a handler, which has custom behavior for something like property accesses, the get and set property operations. These are called traps, second vocabulary word. Then you got your person object. This is the thing, you've got this, maybe it corresponds to a database record, or it's a model in your React app, something like this. You've got this person object that you want to make sure is to which values are being set correctly. So that person object is called a target. That's your third vocab word. And then, and I keep building to this, I will show you the code in a second. The proxy feature in ES6, the proxy primitive, allows me to create a version of person, this person object that I've created somewhere else. It's my model for my app. It creates a version of person which is a proxy for person. That is, it has all of the same behavior except for this added custom behavior provided by the handler for getting and setting values on properties. So this is at a high level. And I'll just say, this will make more sense when we see the example, but to all the rest of your app, to the rest of the world, to the rest of the JavaScript context, there's no way to tell that this person proxy object has these special validation rules. So nobody else can see the sort of restrictions and custom behavior you've added behind the scenes in the object. And again, this is so applicable to a bunch of things. Imagine like you're debugging, and every time your app calls a certain property on, on your config object, you want to like log it. You want to log every time config.app name gets called. This is the same thing. Instead of having custom behavior on set, you might have custom behavior on get that says, if the property is app name, console.log it. So anyway, so this is a very powerful concept, and the implementation is kind of complicated, but you can go on Mozilla Developer Network, just Google proxy examples, and you'll get a bunch of examples. I just want to kind of give you a sense of the power of this feature. And then, with this new proxy object, you can perform those actions that I kind of hinted at earlier. You can set an integer to the age property in this case, and it checks out. And you can try to set a string, and it'll throw an exception because it wasn't valid. Okay, so one more quick review. You've got a proxy, which is this special magic person object that is the combination of the original person object, just a normal JavaScript object, plus this handler where you've written in code the custom behavior that you want to apply to it. So it's proxy equals a target plus a handler, and that's the code above. And proxy, the big capital P proxy, is the new primitive that's exposed in ES2015. This is the primitive that you can't polyfill today. You can only use if the browser natively supports it, because the power of it is just something that wasn't available in ES5 and below. Okay, so let me show you a quick example of this. Have you guys ever used the sources tab, the snippets tab of your developer tools? You can open up these little code snippets that you set before, and here's another nice little feature. This was just added recently. I mentioned I was up all night. I'm still kind of tired. I'm going to turn the theme of my developer tools to dark mode. Yeah, this. You guys are going to remember one thing from this talk, and it's going to be that there's a dark mode in DevTools, and that's fine. It's a really cool feature. Okay, so here is the code for that whole chain of actions that I just specified. And in particular, this is where the magic happens. This object validator is my handler. This is the object that has the special capabilities attached to various types of property access or object access. And in this case, I'm customizing the behavior of setting a property. So I just create an object called validator. This is going to be a handle. And I create a function called set. You don't have to memorize the arguments of this function. Just look them up online. But you can see here, I basically say if the property that set is being called on is age, because I don't want this validation to kick in when I type person dot name or person dot something else. If it's age, I want to check to see whether it's an integer. If it's not an integer, I want to throw an error immediately because I shouldn't be setting a non-integer age to my person object. And if the value is greater than 200, that actually seems a little high to me. But if it's greater than 200, it's not a valid age. And so I also want to throw a range error this time, but I want to throw an error for that too. So this is it. And then I forgot. I get to the bottom, and assuming I didn't throw any errors, the thing you return is the actual value being set to the target's property. So again, property is age, target is that original person object, and you're setting the value of the age they passed in to the property age. So this is not by itself a special object. In fact, it just is an object with a function called set, which, if you call it with these three arguments, throws errors. It's not magic. It's just an object. This is your handler. The magic comes when you take the proxy keyword and you apply that handler to something else. Now, in this case, that something else is just an empty object. But you could imagine I might have my person, model here, and this guy might have a name which is Bob, and it does have age there too. Maybe it's initially set to 0, something like this. You could also put a more complicated person model and apply the handler again to your target object. But we can see the behavior with just an empty object. And Command Enter runs a snippet. You can also right click on it or somewhere. You can right click on it and press run, but Command Enter runs it. Okay, so this has created my handler object, and it's created a new proxy which applies that handler to, in this case, an empty object, and then it's returned a proxy for person, which I'm calling person. So let's see what happens on this person bar. So person dot name is undefined, right? We passed in an empty object, so it's undefined. And so is person dot age, because this was just an example, so let's delete that so it's clear. This empty object here doesn't have an age, so it's undefined. But let me try to set a name. Okay, this looks like a normal object here. I can't tell that it's magic in any way yet. But if I try to set an age, let's try 100 first. Actually, it still looks normal. Getting that normal. But here's where the magic happens. If I try to set age to be a string, let's try old this time, I get this type error. This is super cool. It's just new behavior, and it opens up the door for customization on all sorts of different types of things. So anyways, proxies are powerful. If nothing else, I hope you just go and read the documentation for them or look up another more in-depth tutorial. And proxies are an example, again, of a native ES2015 feature that just can't be polyfilled or transpiled yet. So you should be happy that browsers are finally supporting these things natively, because it means now you can experiment and go try out stuff like proxies. So anyways, so in conclusion, sort of the gist of this whole presentation is sort of threefold. We're in this time where you're still probably shipping transpiled code, but you might be developing based on your own. When you're choosing transpiling, polyfilling, or bundling tools for the code you ship to customers, dig into the details, figure out what it's actually doing. You want to know, how much overhead is this adding to my original ES6 code? How is it affecting the load time of my code, the startup time? What's the total byte of the byte size of the bundle? So really dig into the metrics. They really matter. The second thing is you can start experimenting with ES2015 features natively in the browser. You can get DevTools' powerful debugging help. You can get the easy refresh cycle of not having to transpile before you test out your changes. Start experimenting today. And then finally, well, I already said it. So, and the cool part is you really can start developing in pure ES6 before you decide to actually ship to your users that same ES6. And I think that's a really powerful thing, and this is a time to be excited as all of the browsers are really on the home stretch to 100% completion of ES2015. So as always, you know, if you use a feature and you want it to be optimized, communicate with us, tell us. Chrome's V8 engine, Edge's Chakra engine, WebKit's JSC engine, and Firefox's SpiderMonkey engine, they're all people, and they all have mailing lists. And if you have issues or feedback, please submit it. And thank you very much. My name is Seth Thompson, and I hope I've inspired you to go download the most recent version of one of your favorite browsers and just see what's supported. You will be very surprised that it's close to 100%. All right, thanks, guys.